In this video, I'll present the concepts that are associated with phases and phase changes. That's Walker chapter 17. So the first concept here is latent heat. That's the heat needed to change the phase of something. The phases here that we're talking about are solid, liquid, and gas. So latent heat, for example, is the amount of heat that's required to melt a piece of ice into water, or the amount of heat that's required to boil water into a vapor, a gas. Latent heat also tells us if I have a gas and I want to condense it into a liquid, how much heat do I need to remove from the gas? Or if I have a liquid and I want to make it solid, how much heat do I need to remove from that liquid to change it to solid? Then we have an ideal gas. So ideal gas you've probably learned about in a chemistry class by now. There are some assumptions that are made about an ideal gas. None of these assumptions are perfect, but if a gas is close enough to fitting these assumptions, then it acts very much as an ideal gas. So one of the things is the gas molecules can bounce off of each other in elastic collisions, but never an inelastic collision. And there's no way, so for example, two molecules will come together and stick together. That doesn't happen in an ideal gas. They just bounce off of each other. Also, they bounce off of the walls of whatever container is holding them, again with elastic collisions. And if you took all of the gas molecules and jammed them together into a small space, the amount of space that the molecules themselves fill is very small compared to the size of the container that they're in. The next thing is the internal energy of an ideal gas. So this is related to the temperature of the gas. So as the temperature of a gas increases, that means its internal energy is increasing.